Okay, this lesson is over the telescoping series test, which, as you can probably imagine, is a way to find the convergence state of an infinite series. Now, one thing to note is that the telescoping series test is not tested on AP, either AP or BC. It's not present. However, you are able to use the infinite series test on an exam, and it will be considered valid. It's just that none of the questions were designed with an infinite series test in mind. Now, one last thing I want to point out before you get into the background info is that the telescoping series test is a useful way to not only find the convergence of a series, but the value it converges at. And this is one of the very few series tests that allows that. Okay, so this is less of an equation, more of a description of the infinite or the telescoping series test. So let's just call an infinite series, any infinite series, the infinite series from n equals 0 to infinity of a sub n. This is just the general term for a infinite series. And really this 0 over here should be like a constant, any constant c. Well, if that infinite series, or if a sub n can be modeled as f of x minus g of x, then you can employ the telescoping series test. And again, it's pretty simple. The idea with the telescoping series test is that similar terms will cross out essentially. So let's take a look over here. The idea is that g sub 0 is equal to f sub 1, and that g sub 1 is equal to f sub 2, or sorry, g of 1 is equal to f of 2. And you eventually end up crossing quite a few of these terms out until you're left with something like f of 0 minus g sub n, or whatever, at which point the n will be replaced with an infinity, because we're taking the limit as n approaches infinity. So, like I said, you're just going to replace the n over here with infinity, as that's like one of the last terms as described by the infinite series test. So, and this usually ends up equating to 0 or something. So you end up with f sub 0 or f sub 0 minus f sub 1, so on and so forth, something like that. Essentially, you're just going to end up with a few values. And those values, if they happen to be a true value, not infinity, not something indeterminate, then you can tell that the series converges, and it converges to whatever value you end up with. But the issue with the infinite series test is that you can't, of course, write out all of the terms. So you're going to have to make essentially guesses based on the patterns you see. You can't write out every term because it's infinite. So that is one issue. I'll give you an example right now. Let's say you have the infinite series from n equals 0 to infinity of 1 over n minus, actually, let's change this boundary to n equals 1. 1 over n minus 1 over n plus 1. So as I said first, we're first going to take the limit as n equals, or as n approaches infinity of the first few terms, or I suppose all of the terms. The first few terms plus the general terms. So the first term in the series is 1, and so we're going to, in place of n, we're going to use 1. So 1 over 1 over 1 over 1 plus 1. And you're always going to want to write out a few terms. I like to begin with 3 or so. Plus the second term, which is 1 over 2, minus 1 over 2 plus 1. And then we might as well write out the third term as well, in case you haven't yet seen the pattern, which is going to be 1 over 3 minus 1 over 4. Now, from here, you can start combining terms. Negative 1/2 can combine with 1/2 to equal 0. Negative 1/3 can combine with 1/3 to equal 0. So at this point, all we really have is 1. However, we have yet, and this one, of course, 1/4 will cross out because it's going to combine in a future term. For instance, the fourth term in this series is 1/4 minus 1/5, and so you can see that it already begins to cross out as well. And so that's what I said when I mentioned earlier, that you're going to have to predict a little bit. That's what I had in mind. So now we have to write out, I'd say the last 2 or 3 terms. Let's start off with the last third to last term, which is going to be 1 over n minus 2 minus 1 over n minus 1. That's because this term we're substituting instead in place of n, we're going to use n minus 2, as this is the third to last term, plus 1 over n minus 1, as this is the second to last term, minus 1 over n. From here, we'll just continue on this on another line, plus the last term, which is n. So in place of n, we're going to use n. So our last term is 1 over n minus 1 over n plus 1. And I believe you have to put a plus dot 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 despite this being the last term. So from here, we just need to cross out the last few terms. So start over here. 1 over n can combine with negative 1 over n to equal 0. Negative 1 over n minus 1 plus 1 over n minus 1 is equal to 0 as well. And if we were to take the fourth to last term, we'd end up with negative, or 1 over n minus 3 minus 1 over n minus 2. And I'm just pointing this out so you can visualize what we're going to cross out next, which is going to be 1 over n minus 2, as this over here would fit in here, and essentially we'd be able to cross this out as well. I'm just showing you this because in hopes that you'll begin to see the pattern. And of course, 1 over n minus 3 will cross out as well, because although we don't have the term yet, or we don't have the term depicted yet, it's still there essentially, or there will be another term, I should say, that will combine with it to equal 0, if that makes any sense. So essentially all of our terms are crossed out now. So what we have now is the limit as n approaches infinity of 1, as you can see over here, minus 1 over n plus 1. Now, this limit is in fact equal to 1, because if we were to use infinity in place of n, we'd end up with negative 1 minus 1 over infinity plus 1, which is infinity. And anything over infinity is equal to 0, because it's just such an infinitesimally small number that it might as well be 0. So the series that we originally started out with, the series from n equals 1 to infinity of 1 over n minus 1 over n plus 1, converges by the telescoping series test, and in fact, it converges to 1. Okay, so this is practice problem 1 of 2. At first glance, the series seems a bit similar to the last, but it's going to be a bit more confusing just based off this second fraction here. So what we're first going to do is we're going to equate this to the limit as n approaches infinity of the first term, which is 1 over 1. We can just write that as 1, minus 1 over 3, plus the second term, which is 1 over 2, minus 1 over 4, plus the third term, which is 1 over 3, minus 1 over 5. And although I said you may want to go out to 3 terms, you can, of course, continue and add a fourth or a fifth, as many as you see fit. So the fourth term is going to be 1 over 4, minus 1 over 6. So let's begin. Before we go into the general terms near the end, let's begin crossing these constants out. So we can see that there is no -1 present, and so we don't cross that out. However, there is a 1/3 present that corresponds with this -1/3. So we can cross those out, as those two can combine to equal 0. Now, we can move on to the second term. 1/2 is not seen anywhere else, and it will never be seen again in this infinite series. So -1/2 does not combine, 1/2 does not combine with a -1/2. So we can leave this here. Now 1/4, we can see that -1/4, we can see that there's a 1/4 over here. This 1/5 crosses out as well. If we were to take the fifth term, it'd end up with 1/5 minus 1 over 7. And so we can see that this crosses out. The -1/6 crosses out as well, as the sixth term is 1/6 minus 1/8. So we can cross that out. And of course, all subsequent terms thus far will cross out, such as 1/8 and negative, or such as -1/8 and -1/7. So what we have so far is 1 and 1/2. Okay, so now we have to move on to the general terms. I'm going to write 4 general terms, as I like to call them, the last 4, those being n over n minus 3, n minus 2, n minus 1, and n. So for this fourth to last term, we're going to use n minus 3 in place of n. And then we'll write the third to last term as well. I'll continue it on this line. Then the second to last term. And then finally the last term, which is going to be 1 over n minus 1 over n plus 2. And of course we have to add the plus dot 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 near the end, as that's just required for some reason. So now we can once again start crossing out terms. Speaking with the end here, 1 over negative 1 over n plus 2 does not have a corresponding 1 over n plus 2 anywhere. And so we can leave this. However, 1 over n does. So there's a negative 1 over n over here. Those can combine to equal 0. Now we can take a look over here at the negative 1 over n plus 1. As you can see, 1 over n plus 1 is not seen anywhere. So this term does not cross out. 1 over n minus 1 does have a corresponding negative 1 over n minus 1. And so we can cross those out. 1 over n minus 2 does not, or sorry, it does have a corresponding term. However, it's not seen here. If we were to take the fifth to last term, we would end up with a negative. We would end up with a negative 1 over n minus 2. And so we can cross that out. Although we haven't depicted it here, if we were to expand this one more term, then we would see it. 1 over n minus 3, again, we will have to cross this out because there is a negative 1 over n minus 3. It's just not seen here. I believe it's going to be the sixth term will feature negative 1 minus 3. So we're really left with only 4 terms left. So we can equate this to the limit as n approaches infinity of 1 plus 1/2 minus 1 over n plus 1 minus 1 over n plus 2. Now, this is equal to 3 over 2. You can see that if we were to take the limit as n approaches infinity of negative 1 over n plus 1, we'd end up with negative 1 over infinity, which is 0. Same goes for this term over here. So that's why we end up with 1 plus 1/2, which is equal to 3 over 2. So we can say, therefore, the infinite series from n equals 1 to infinity of 1 over n minus 1 over n plus 2 converges to 3 over 2 by the telescoping series test. Okay, so this is practice problem 2. At face value, it looks as if this infinite series can't be solved using or the state of convergence can't be found using the telescoping series test. However, you'd be mistaken because we can decomp this fraction. I've made a video on decomping fractions in the past if you're not familiar with it, but essentially this is equal to a over, well, we might as well expand this denominator first. X squared plus 9x plus 20 is equal to x plus 4 times x plus 5. And I featured a video, as I just said, going over decomping or just decomping fractions. I'll put a card right here if you're unfamiliar with it. But essentially, this is equal to a over x plus 4 plus b over x plus 5. From here, we have to find both a and b. So 1 is equal to a times x plus 5 plus b times x plus 4. We're going to begin by letting x equal negative 5 And if that's true, then we end up with 1 equals negative b, meaning b is equal to negative 1. From here, we have to let x equal negative 4, meaning that 1 is equal to a. Okay, so from here, we just have to substitute a and b in, meaning that this infinite series is equal to 1 over, or I should say that the infinite series is equal to the infinite series from n equals 0 to infinity, which I'll make space for that in a moment. The infinite series from n equals 0 to infinity of 1 minus 1. So we've just expanded this infinite series. From here, we can now employ the telescoping series test as the terms, because a sub n is equal to the difference between two functions, essentially. So what we have to do now is just find some of the terms, or find some of the first few terms and some of the last few terms. So we're going to take the limit as n approaches infinity of the first term, which is going to be 1 over 4 minus 1 over 5, plus the second term, which is 1 over 5 minus 1 over 6. Might as well take the third as well, which is going to be 1 over 6 minus 1 over 7. We could continue onward using the fourth and the fifth term, but I believe you may already be able to see a pattern. It's quite evident. We'll get back to simplifying in a moment. We're going to write the last few terms. So we're going to write the last 3 terms, which as always will be n minus 2, n minus 1, and n. So yeah, we might as well do that now. I really should have used, I don't know why I modeled this infinite series with x's rather than n's, but let's just quickly change those. We're going to substitute n in place of x. Doesn't really change anything. I sort of just messed up with the limit, but it's just going to make this simpler. So we're going to use, in place of n, we're going to use n minus 2, so we end up with n plus 2 minus 1 over n plus 3. From here, you can write the second to last term, which is going to be 1 over n plus 3 minus 1 over n plus 4. And finally, we can add the last term as well, which is going to be 1 over n plus 4 minus 1 over n plus 5. And from here, I might as well add the plus dot dot dot. From here, we can begin simplifying terms. So negative 1/2, negative 1/5 combines with 1/5 equals 0, as well as the 1/6 and the 1/7. Although, again, we don't have 1/7 featured here, it is very clearly going to be the next term. Now we can begin simplifying or combining the last few terms. Negative 1/5 does not simplify or does not combine with negative 1 over n plus 5 does not combine with a 1 over n plus 5 to equal 0. And so we'll leave this term alone. However, 1 over n plus 4 does, as well as 1 over n plus 3. And if you see the pattern, you'll notice that 1 over n plus 2 will as well. If we were to write the fourth to last term, you'd notice that we'd have a negative 1 over n plus 2. So we can equate this, what we have so far, to the limit as n approaches infinity of 1/4 minus 1 over n plus 5. As you can see, those are the only 2 terms that have not yet been simplified because they can't. And this is equal to 1/4, because if we were to substitute n or infinity in place of n, we'd end up with 1 over infinity, which is 0. And so our final term, or I should say that this series that we have, the infinite series from n equals 0 to infinity, of 1 over n squared plus 9x plus 20, sorry, n squared plus 9 times n plus 20 converges to 1/4 by the telescoping series test. Now, the Taylor covering series test in general is just really great. I believe it was used to find the value or approximate the value of natural log 2 or something similar. It's very versatile. However, that's it for today's lesson. If you have any suggestions, please put the suggestions in the comments below. Thank you.